Okay, so we're going to look at some counting rules, and some of this, again, you don't necessarily have to use Excel to calculate, but we will talk about how to do the calculations specifically in Excel when we get to the fields that need it. So let's look at three examples, because there's three different counting rules: multiplication rule, permutations, and combinations, which are sort of the most common in that you encounter in a probability and statistics course. There are other counting rules for other scenarios. If you take discrete math, you will find that there are lots of other things that you might have to consider when doing counting in particular circumstances, but these are by far the most common scenarios. So our first example, we have a license plate in New York State that consists of 3 letters followed by 4 numbers. Well, let's assume that the letter O is omitted because it looks too much like 0. So in this circumstance, how many possible license plates of this configuration are possible? Now, the first thing we have to figure out is what kind of counting rule is this? And the kind of counting rule this is a multiplication rule. And one of the reasons that we know that is because in a license plate, you can have more than one letter that reappears, or more than one number that appears multiple times in the same license plate. So AAA 0036 is a perfectly valid license plate number. The fact that it has 3 A's in it is not a problem. In our other examples that we're going to look at later on, you're not allowed to repeat things. And so that would be a consideration in those cases. But in this problem, not only are we allowed to do repetition, but that is, what we would expect. If you were drawing things out of a bowl, but you were putting them back in the bowl before you took the next thing, that would be another case where you are allowed to repeat things. But in this case, we're simply selecting from the same pool of letters and the same pool of numbers each time. So the multiplication rule applies. Now, we're going to separate our license plate out into 2 pieces. We're going to separate out the letter part, and we're going to separate out the number part first. And in fact, we want to think about like each individual character in the license plate. For the letter portion of the license plate, each character can be any letter but O. Now, how many letters are there to use? Well, normally there are 26 letters in the alphabet, but if we eliminate O, then we have 25 letters in the alphabet. How many times are we using letters? Well, we're using them 3 times. So we're going to pick a letter, we're going to pick a letter, and we're going to pick a letter. How many numbers are there to be used? So how many single digit numbers are there? Well, there's 10 of them, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, but then also 0, and that's our 10th one. So there are 10 possible numbers. And how many times are these numbers used? Well, there's 4 numbers. So number, 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 number. So there's 4 of them. So the total count that we're going to end up with then is going to be 25 raised to the 3rd power. This is 25 times 25 times 25. So 25 for the first letter, 25 options for the second letter, 25 options for the third letter. You can see why this is called the multiplication rule. And then for our numbers, there's 10 options for the first letter, 10 options are for the first number, 10 options for the second number, 10 options for the third number, 10 options for the fourth number, which is 10 to the 4th power. And we get a very large number. Put some commas in it so we can read it more easily. 156 million. So in this case, New York has, a fair number of people. There's like 10 million in New York City alone, and then there's the rest of the state. So this license plate configuration they can use for a while before they have to recycle and try a different configuration. And that's the point. If you have a smaller state, you maybe can get away with 3 numbers. If you're in California, then they have 9 characters in their license plates, because they would cycle through these too quickly. All right, let's look at our next rule. A T-ball team has 14 players, and the coach needs to put 10 players on the field in each inning. How many different ways can he put players on the field? So we want to know what kind of counting rule this is. So we want to think about how this actually works. If a T-ball team starts out with 14 players, let's say the coach starts picking people to put on the field in different positions. So he picks somebody out and he says, okay, you're going to go stand on the pitcher's mound, even though there's no pitching going on. And then he takes another person out of the team and he puts them over on first base, and then somebody else for second base, and on and on. After you put somebody on the pitcher's mound, they're not available to play first base anymore. So the first time he picks somebody to play a position, he has 14 options available to him. But the second time that he picks somebody, he has only 13 options because he's used one of those options already. Now we've picked 2 places. Now there's 2 people used. There's only 12 people left over. There's 12 choices to put on the next one. So you see this pattern. We could do this by the multiplication rule. Start with 14 and then count out 10 characters. 14 times 13 times 12 times 10 times 9 times 8 times 5 times 7 times 6 times 5 until we got all 10 people on the field. But there's a faster way to do this. This fact that we're not allowed to reuse people means that this is a permutation rule. Now, permutations care about the order because it is different. It's a different configuration of the infield if you put player A on the pitcher's mound and player B at first base, whereas if you switch them. Maybe player A doesn't have really great reflexes and you really don't really want him standing right in front of the T-ball. But on the other hand, that is different. And so the differentness is what matters. The order that you specifically choose people for which position doesn't matter, but the fact that you're putting them in specific positions does matter in this context. So we want to know how many people the coach is picking from. There's 14 options and he's picking 10 of them. Now, because this is a permutation rule, there is a built-in formula in Excel to do this count. And not too surprisingly, you can just start spelling the word permute. We want the permutation function is the permute function. And the number that goes first is the number you are picking out of. It is always the larger number. And the second number you're choosing is the number that you are choosing from. And again, we get a really big number. We put some commas in it. So there's more than 3 billion ways of doing this configuration. If you have a 14-player T-ball team and you need to field 10 players at positions in every inning. Now, the technical formula for this, using the syntax in Excel, with the number you're choosing from first and then the number you're choosing second, the formula is n factorial divided by n minus r factorial. The explanation points are read as factorials. The factorial is also itself a formula in Excel that you can use. And basically the factorial calculates, if you're doing 14 factorial, it calculates 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then it stops. So we could actually use the factorial formula in Excel to do this calculation. N minus R is 10 in this case, is basically telling us how many terms at the end we have to cancel off from the 14 factorial. So we said if we were using the multiplication rule, 14 times 13 times 10 times 9, 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 is our 10th character. We need to get rid of 4, 3, 2, and 1. And so this will become 14 minus 10 is 4 factorial. And so it's telling us to cancel off these last 4 terms. So we can use factorial, fact 14 divided by fact. And we can even just spell it out, 14 minus 10, which is 4. And we'll get exactly the same number that we got before. So we could use this formula, but it is built into Excel. And so we don't really have to use the factorial formula. And then our last example is our third counting rule. This is a 5-member committee is being staffed from a 25-person full-time faculty pool. How many different ways can the committee be formed? In this case, repetition is not allowed. And does order matter? In fact, it does not matter, because when you're on a committee, everybody is just on the committee. There's nothing special about being chosen first or second or fifth. So this is called a combination rule, because we care about the way that people are joined together sort of in a group, but not the order in which they're specified. So how many people are we choosing from? Well, we're choosing from a 25-person full-time faculty pool. How many people are we choosing? The coach is not choosing anybody. Wrong problem. We're choosing from 25 full-time faculty people, and we're choosing 25 faculty members. And so our count, again, you just have to start spelling the word combination, and you get combin. It's not the other one, it's combin. And then the number you're choosing from, the bigger one always goes first. And then the second one, the number you're choosing goes second. Combinations, even if we use the exact same numbers, are always going to be smaller than the number of permutations of the same thing, because you just imagine like 1, 2, 3. Well, if you 3, 2, 1 is the same configuration, you're having fewer options because you don't care about the order. In this particular case, 53,000 member possible different configurations of this committee. Now, again, the combination formula, if we wanted to do it out the sort of old-fashioned way, it looks kind of like the permutation formula, n factorial. It starts out n minus r factorial, but then there's an extra r factorial in the denominator. And that's that extra r factorial that is, again, sort of accounting for the fact that, okay, I have these 5 people I've chosen, but I don't actually care what order they're chosen in. And so we're taking out the count of those different kinds of combinations. How many ways can I rearrange those 5 people? I don't care about that. So I'm dividing that out. And again, we can use the factorial formula if we wanted to. 25 factorial divided by, do be careful with the parentheses. Fact 25 minus 5, and then times, you do have to specify the multiplication explicitly, fact 5. And again, when you do it correctly, you'll get the same count that we had before.